All right, welcome to section 7.3. So solving multivariable linear systems. So we're talking about linear systems here, with the exception of the last slide, we'll get a little bit weird. But we're talking about having multiple variables and thus multiple equations. So we're going to start off with something pretty easy, introductory. Looking at this equation, I can see that there are 3 equations and 3 variables. That's something that I sort of need, depending upon the number of variables. What I know is that z is equal to 2, and so that really is already solved. What I can do with that is substitute it into this middle equation, because that will allow me to solve for y. So from that, I would get y plus 3 times 2 equals 5. So y plus 6 equals 5, so y equals -1. At that point, I can now take this equation that has x, y, and z, and substitute in my z and my y. So I'd get x minus 2 times -1, plus 3 times 2 equals 9. So I get x plus 2 plus 6 equals 9, which means that x is equal to 1. When I'm writing my final coordinate then, it goes always in order, so x, y, z, alphabetical order. So I'll have 1, -1, 2. Obviously, we're not going to be able to check this using our graphing calculators, so you have to have a little bit more strength and confidence that you know how to do these problems. But 7.2 should be in good preparation. Okay, so it's not usually going to be that easy. So what I'll talk through is some of the strategies that you just sort of want to be thinking as you're going through this. So first strategy, I see here that I have 3 equations, 3 variables. However, there is a variable missing from one of these equations. Automatically, that is the variable that I want to eliminate out of the other 2 equations. So this middle equation, I'm sort of just fading him out right now. I'm not going to use him. All I'm going to do is bring that equation down. Yeah, I guess I'll bring it down. So leave sort of a lot of space here. And I'm just going to bring this down. -x plus 3y equals -4. So, cool. Dealt with that. Now, looking at these other 2 equations, the variable that is missing here is the variable I want to eliminate. Because if I now just look at these 2 equations and eliminate z, I will have another equation that is in terms of x and y, which will allow me to combine it with this one. So if I'm going to eliminate z, I'll switch color just for convenience. On the top, I'm going to multiply by 5. On the bottom, I'll multiply by 3. And I want one of these to be positive, one of them to be negative, so I'll just make that a -5. Then distribute this throughout this equation. I'll have -5x plus 10y minus 15z equals -45. And I'll have 6x minus 15y plus 15z equals 51. Now, if I combine these, my z's cancel off, so I'm left with x minus 5y equals 6. Well, okay, cool. Why is that helpful? Because now, looking at these 2 equations, the blue equation being the one that I got when I combined the first and third, and the red equation being my original second equation, I can now solve this system. I don't have to change anything either. My x is already canceled. So I'm left with a -2y equals 2. So y equals -1. When I want to talk about now, where do I substitute that into? I can substitute it into these blue equations, but those still have a z. So really what you want to do is substitute it into one of these equations, boxed off by the pink, because that will allow me to solve for x. I'll pick this top one just because, I don't know, it has a positive x. X minus 5 times -1 equals 6. So I get x plus 5 equals 6, which means x equals 1. Now I have both x and y, so I can pick either of these blue equations, or either of these blue equations, to substitute into it. It doesn't matter which one. I will pick the top one for convenience. I get x, which is 1, minus 2 times y, which is -1, plus 3z equals 9. So 1 plus 2 plus 3z equals 9. So 3z equals 6. So z equals 2. Again, writing a coordinate in alphabetical order: 1, -1, 2. It just so happened that, we got the same thing. Coincidence. I promise not all the answers will be 1, -1, 2. That would make this chapter much too easy. So, let's do an example where we don't get that. So just looking at another example, this is actually a slide that you already have. So that's not the right problem. Let's just act like that's not there. Let me see really quick. I messed up. X plus 3y minus z. You can come by, scream at me. Let me just write this real quick. I know it's taking more time, and I just like to eat up all of your time. Okay, yeah, so we've got this system. If I did that other one, it was just going to give us the same answer because it was the same problem. Looking at this system, I have 3 equations and 3 variables. None of them are missing any variable. So all you want to do is pick, probably should have left myself a little bit more room. So give me, just one more second. I am so needy here right now. Oh shoot, I don't want that either. Okay. You know what? We'll just leave it. That's fine. You hate me. What I want to do here is pick out which variable do I want to eliminate from 2 equations. So if I'm looking at this personally, what I got rid of looks like I got rid of y. And it doesn't entirely matter. The x's are sort of easy to get rid of. Z sort of easy to get rid of here as well. I'm going to get rid of y. So what I want to do is look at just these top 2 equations and say, well, what would I have to multiply by? So if I looked at this middle equation and said, I'm going to multiply that by 3, I would have 6x minus 3y minus 6z equals 6. And I still have that same top equation, x plus 3y minus z equals 1. Combining these then, I get 7x minus 7z equals 7. In the same regard, I want to also get rid of y, but I want to get rid of it using this third equation. So what I'm going to do now is say, okay, well, I'm not going to multiply this by 3. I'm going to multiply it by 2. But I'm going to combine it with this third equation. So that would give me 4x minus 2y minus 4z equals 4, and x plus 2y minus 3z equals -1. If I combine going straight down then, I get 5x minus 7z equals 3. So what was great about this? Well, now I've got these 2 equations that are both in terms of x and z. So if I rewrite those, 7x minus 7z equals 7, and 5x minus 7z equals 3. I can combine these by subtracting straight downward. If you feel more comfortable, multiply one of these by a -1, just to change that sign. 7 minus 5 is 2x. -7 minus -7 would cancel. And 7 minus 3 is 4. So I get x equals 2. Once I have x, I can go to either of these 2 equations and substitute in. I'll just pick this one because I don't know my pen's here. 7 times 2 minus 7z equals 7. So 14 minus 7z equals 7. -7z equals -7. So z equals 1. I have x and z. I substitute into any of these original equations in order to get y. I'll pick the top one. Yeah, I'll just pick the top one. So I get 2 plus 3y minus 1 equals 1. That gives me 1 plus 3y equals 1, 3y equals 0, so y equals 0. Last, we write our coordinate, x comma y comma z, so 2 comma 0 comma 1. Getting y equals 0 does not mean there's no solution. 0 is just a number. So I got 0. No big deal. All right, let's do another one. And, this is actually the problem, so it'll be a little bit less confusing. So looking at what I want to eliminate, it doesn't really matter. I'm going to go with the x's because I already have a 3 and a 3. So if I'm looking at just these top two equations, I am going to subtract. 3 minus 3x would cancel. I'm just going to write my solution up here. Sort of cool. 5 minus 3 is 2y. 9 minus 5 is 4z. And 0 minus 1 is negative 1. That's a 4z. So sort of cool here. I subtracted going upwards. That is totally fine as long as you do it for each one of those terms. Again, if you don't feel comfortable, organize this separate, different. That's fine. Now in blue, I'm looking at, that's a not very good line. I'm looking at these bottom two equations. So I'm actually going to just get rid of that pink line. Cool. I'm looking at these bottom two equations. Those x's don't cancel as easily. So I'm going to have to multiply both equations. Here I multiply by 5, here by 3, and 1 negative. So I get 15x plus 25y plus 45z equals 0, and negative 15x minus 27y minus 51z equals 0. Now those cancel. I get negative 2y minus 6z equals 0. And I bring down my other equation now. Positive 2y plus 4z equals negative 1. Conveniently, these can add straight down. So I get negative 2z equals negative 1. So z equals 1/2, a fraction. Scary. Now we go back and substitute that in. So z is 1/2, which means either of these are good things to substitute into, because both of them are even numbers, and I can take half of an even number. I'm gonna pick this second one actually, and say 2y plus 4 times 1/2 equals negative 1. Now you might be thinking, why did I pick that second one? This has a negative, and you're not particularly awesome at negatives, so you have some strategies here where maybe you can try to avoid making that mistake. I just want that to look a little bit more like a 0. It's bothering me. I get 2y plus 2 equals negative 1. So 2y equals negative 3. So y equals negative 3/2, another scary fraction. Now I have z and y. I can pick any of these equations to substitute into. I will pick the none of them are particularly easy. I'll pick the middle one because it's all positives. It gets 0. I don't know. Why not? 3x plus 5 times negative 3/2 plus 9 times positive 1/2 equals 0. That gives me 3x minus, 15/2 plus 9/2 equals 0. That gives me 3x minus 6/2, which is 3. And you can sort of see here, x is equal to 1. Or you can finish the solving. Final answer is the coordinate 1 comma negative 3/2 comma 1/2. So again, your strategy with these ones that don't have anything that's missing is, pick a variable. Eliminate it in the top two equations. Eliminate it in the bottom two equations. It doesn't even have to be the top two. You could do like first and third and second and third. Just eliminate it in two of the equations and then solve the system of the remaining equations. All right, and then we have this, super cool one because it throws it back to chapter 3. And I know that you loved chapter 3 and you loved logarithms. So we've got log base 2 of x plus y equals 2, and negative 2y minus log base 2 of 2x equals negative 1. So the first thing I would look at is getting rid of these y's. If I multiply by 2 and sort of reorganize. 2 times y gives me 2y plus, this would be 2 log base 2 of x equals 4. So now my y's will cancel. Here I have a little bit of an issue. A lot of you are going to want to combine this. But these do not have the same argument, which means they're sort of like not like terms. So this is just 2 log base 2 of x minus log base 2 of 2x equaling 3. And now you might be thinking like, well, what am I going to do from there? And now we got to use some of our properties. I know that's crazy. Again, we're like asking you to remember something. It's been a long time. One of our properties of logarithms was multiplication inside an argument could be split. So this becomes 2 log base 2 of x minus, and we said that multiplication could be split as addition. So this becomes log base 2 of 2 plus log base 2 of x. And then next, log base 2 of 2. What log base 2 of 2 means is 2 to what power gives me 2? Well, that would just be 1. And I'll bring everything else down, just, so that we can see each step. All of this is still equal to 3. If I distribute that negative then, I get 2 log base 2 of x minus 1 minus log base 2 of x equals 3. Now, these are the same terms. So we can subtract them. And all you're doing is subtracting, if I had like 2x minus x, you're only subtracting the coefficients. So this becomes log base 2 of x is equal to, and I'm going to add this one over, 4. And then the way, again, that a logarithm works, you're taking this base and saying, well, 2 to the 4th power equals x, which means x equals 16. So there's a lot there. You have to remember those properties of logarithms, the fact that multiplication can split to addition, the way in which a logarithm works, the fact that I'm saying log base of something means I need to know what power gets me to that. Now we're not done. We've only solved for x. Y is easy to solve for, though. Looking at this top equation, log base 2 of 16 plus y equals 2. Log base 2 of 16 means 2 to what power gives me 16, which is 4, plus y equals 2, so y equals negative 2. Our coordinate then, 16 comma negative 2. So it's sort of a cool thing with systems here, it doesn't have to be linear or quadratic, which is stuff that you've seen, or cubic you've seen. We can even do it with logarithmic. We can do it with trigonometric functions. I know, you're looking forward to it. So get started. If you have worksheet 3, get started on worksheet 3, check over 1 and 2, and make sure that you have a general understanding of especially the strategy to apply and which variable to eliminate. Sometimes it's smarter to eliminate one, but it works in most cases to eliminate any. Here, it doesn't work to eliminate any. You have to get rid of z first. All right, have fun.